Okay, welcome back to the class. So in this today we have already done this algebraic properties and this order property of real numbers. So basically what we are going to do here is the we'll be doing this idea of this countable set, uncountable set, and this is this topic would start. So neighborhood of the set will do it later on. Okay? It's not a very big thing. So it will be good if we do it with this intervals and limit points and isolated points. So we'll start from this idea of countable sets. Before going to the countable sets, I would like you to go through a few things. The first thing is the function. So what is a function? So you know function is uh, it is like a machine. Okay, it takes an input and gives you a output. Or in set theoretic view, you can say that function is a special kind of subset of A cross B if the function is from A to B. So let's discuss this informally. So it's a machine that relates an input to an output. Input means incoming things and output. Okay, but the relation is the function. Okay, so you see, normally function is denoted by fx, where the f is the name of the function, x is the input, and this whole thing fx is the output. Okay, so this is the thing. So next you can see there are inputs in function. There are three component: input, output, relationship, and output. Okay, so you can see these are the inputs, this is the relationship, this is the output. So what is a function? Function is multiplying by 2. So 0 multiplied by 2, you get 0. If you 7 multiplied by 2, you get 15. So you can see what will be the what will be the uh, output of 50. If input is 50, output will be 100. Okay. There are lots of examples of functions, you know. So you can just go through that. This x squared is a function, and this x cubed plus this sine x tangent. Okay, these are examples of functions. Similarly, the name of function can be other than f also. It can be z, it can be anything. It can be marmalade. Okay, whatever it is. Marmalade of x can be anything. Okay, we don't care. It's a name only. As we are basically lazy brand of people, so we normally use an alphabet from an English alphabet. So normally f is used. So as it is function, the spelling of function is spelled with f, so we take f. Okay, that's our lazy. But it can be anything, anything. Okay. For example, sine is a special kind of name only of a function where we find out the sign of the value. Okay, so that is the thing. So why I am doing this? Because this is going to be we are going to use functions explicitly. So that's why I'm just giving you a revision of the things what you already know. So here in function, this x is only a placeholder. Whatever comes in x, it translates to the formula. Okay, so whatever it comes, we don't care. Okay, the number can be anything. So it will just translate to the formula. You see, if this is the formula of this is the function fx is what 1 minus x plus x squared. So whatever x is there, you just put that x here. It is a placeholder. Okay, if input, it is the input only. Okay, so this is the thing. So here you can see f of a q is given by this, f of capital A will be this, f of theta will be this. Okay, so whatever you put, we don't care. So f of 2, you see, of 2. So we replace whatever it is uh, in place of x, we replace the thing. So 1 is there, so 1 this will be 1 only. So as you have x and x square, so you just put 2 and 2 square. It's a placeholder. So whenever you get something similar to this inside the bracket, in the expression, you just replace that thing. Okay, whatever it is there. So if you want to find f10, so what happened? So in place of 10 you got x, you got 10. So what, in the right hand side also, wherever there is x, you replace that by 10. So that's it, nothing more. Okay, it's that simple. Next we have few kinds of functions, important kinds of functions. So first one is the injective function, then we have surjective function, and we have bijective function. This is very important to us. So what is a, you see, this is an peculiar example of not a function. Okay, here A are given by blue balls, and this B are the yellows. Okay, so you see you have two arrows from this one element here. No, this is not a function. Function means whenever you have an input, output should be always fixed. You cannot have two outputs. Okay, only one output should be there for every element in this. You see, this is a function. Okay, you see, for this and this input, you are getting same value. We don't care about the values. Okay, it can be same for all the elements, but only problem is only one of the one element here. One input cannot have more than one output, and every input should have an output. So you can see there is a general function, there is an injective function. Each one is going to when in for every input, outputs are different. Okay, if this happens, we call it what, injective. But it is not surjective. Why not surjective? Because one element here is left out. It doesn't have a pre-image. So whenever you have a function like this, when each element is going to a unique element, means no element from the codomain has two pre-image, then we call it what, a injective function. Okay. Surjective function means what? Every element of the codomain is in the range. Okay, means every element has a pre-image, then we call it what, surjective. Okay, but you see it is surjective but not injective. Why? Because this element has two pre-image. In injective case, what is the condition? Every this each element has at most one preimage. You see, this doesn't have a preimage. This is one preimage. This one preimage. Okay. And what is a bijective? If a function is both injective and surjective, we call it bijective. You see, it is an injective function. Each element in the codomain has only one preimage, and no points are there in the codomain which is not an image of at least one point. Okay, so therefore this is called bijective function. So in bijective things, you have to realize this one, that if you have a bijection from A to B, you can see the number of element in B is equal to number of element in A. Okay, so this is the thing. So whenever you do counting 1, 2, 3, 4, for example, we are saying that there are 4 cows in the field. Okay, present in some field. Okay, so what we exactly do is, we see a cow here. This is a cow, for example. This is one cow, this one cow, and this is one cow. So we what do? We make a function from this one like this. Okay, 1 is going to one cow, 2 is going to one cow, 3 is going to one cow, 4 is going to one cow. So how many? 4. So you can see that if you have a bijection from set of elements 1, 2, 3, 4 to the number of cows there in the field, if this type of bijection exists, we say that there are 4 cows. Okay, means that there are only 4 cows if you have a bijection from the set 1, 2, 3, 4 to the all cows. Okay, that is okay. So that's how the counting works. Actually, in count, whenever you do counting, we are actually trying to find out the bijection from the set 1, 2, 3, 4 dot n. Okay, so what is the smallest n such that you have a bijection from this subset, okay, to the things you are counting. For example, you are counting a bunch of apple. Okay, you will just think you take a bijection like this. 1 goes to one of the apple, 2 goes to another apple, 3 goes to another apple, 4 goes to another apple. For example, there are 10 So this is 10. Okay, so 10 goes to the last apple. So this is the bijection. That's how you count. Whenever you do counting, actually we are finding out bijection. Okay, so that is the thing. Now to all this, I think this will be enough for our introduction. So we can now go to the main theory of finite, countable, and uncountable sets. Okay, okay, that's enough. Okay, let's go to the definition. Okay, let's go to this thing. So injective are also known as what? One-to-one function. Surjective are called on-to functions. Bijective are called one-one on-to functions or one-one on-to correspondence. Okay, you know what is a graph? Graph is like this. So this is not a graph of function of y. Whenever you have a function, you draw a vertical line, it should cut at only one point. Okay, if 2 points are there, so it is not a function. Okay, so this is the thing. And injective function will be like this. Okay, no horizontal line also will not cut the graph in 2 points. Okay, so that will be an injective one. Injective one. So there is a formal definition. If f is an injective function, if and only if fx equal to fy, means if images are equal, then the pre-image are equal. Okay, so that is the origin, the definition of injective function. So whenever you have to show whether a given function is injective or not, we start with let fx equal to fy, and we'll put on the formula of the function, and we'll do some simplification, and we'll try to get x equal to y. If we can get that, we'll declare that the given function is what? 1 or injective. Okay, similarly, for surjective, you have to find one. You take a point in the codomain and try to find out one element in the domain whose which is the preimage of the point you have earlier taken. So you see, if f is a function from set A to B is surjective. Okay, if and only if for every y in B, means you take element in B, then there is at least one x in A, so that fx equal to f. Okay, so otherwise this is the surjective. Okay, fa equal to fp means image of all the elements of A is equal to B. Okay, if it is equal, then we call it surjective. Okay, so bijective means a function from set A to B is bijective if for every y in B there is exactly one x in A, so that fx equal to fy. Means you have a B set here. So from the B set you take an element. Okay, from the set B you taken one element. This is the element I've taken. Okay, so what happens for every element in B you'll have one x, such that fx x is going to what? Y. Under this, if this thing type of thing occurs, we call that f as bijective. And bijectives are also known as one-to-one correspondence, or it is both injective and surjective. Okay, so this much is enough, I think, for the beginning. So we'll do the rest in the next video.